All right. Thank you very much, Dave. I appreciate you. And thanks everybody for being here. So we're going to be talking about supply chain and a slight variation upon the theme of supply chain. So yes, it's still supply chain, but there's some really interesting deviations from the norms and deviations from kind of the expected use case that can pop up. Now, some of this is going to depend on the way in which you use generative AI and or LLM applications, but understand that how you use them today, it's just going to evolve and evolve and evolve. And if anything, this is going to get more robust and more complex in my expectation anyway. Now, I'm Seth. I'm a SANS faculty fellow, been teaching and authoring for SANS for quite a few years. And this content is related to Security 511. And so that's continuous monitoring security operations. It's defense. It's blue team, it's defense, focused on protection and detection so that hopefully we can respond. And one of the things that Eric Conrad and I do, the co-author, one of the things that Conrad and I do whenever we're writing content is we like to have a pop cultural touchstone. And we're nerds. We're total nerds. So I think I chose this one. We've like jumped back and forth. We've done like sneakers and Game of Thrones and some others, but this one was Battlestar Galactica. And so before we dive in, right, before we jump into the supply chain security, we kind of lucked into the use of Battlestar Galactica, especially as relevant to my talk here. So we'll see why in a second. So although you can rethink your life, and you probably should if you've not really attended to Battlestar Galactica at this point. But here's like the only thing you need to know is that Cylons, right, takes place in the future. Cylons are evil alien robots that mean to like destroy the human race. And here is like the crux of like anything Battlestar Galactica is that Cylons can look like humans. Okay, so you never know. You're interacting with somebody, no idea if they're a human, Cylon, whatever. Okay. Now, one of these humanoid Cylons, number one, he interesting character, very interesting character. And one of the things he says that I love, that I think steps right into Gen AI and LLMs, is I don't want to be human. Do you see the absurdity of what I am? I can't even express these things properly because I have to conceptualize complex ideas in this stupid, limiting spoken language. Now, I think that's awesome. It was just a great episode and a great quote and great character. But something else that it really reminded me of, I mean, these are alien robots, right? Now they're pretty darn advanced, pretty darn capable. And that reminded me of this idea of emergence. And emergence is something you may or may not have heard about or read about or thought about with respect to machine learning, with respect to LLMs, with respect to generative AI. And this graphic that we have playing here, this is a fun one. It came out when Google released Palm 2. And one of the things they're showing, like what the graphic is showing, is that as our language models get bigger and bigger and bigger, then suddenly the capabilities can just explode, right? The capabilities can explode. And what's especially interesting here is that there can be capabilities that we didn't anticipate. Now, that's the idea of emergence. And so emergence, like as we get bigger and bigger and bigger, suddenly it's like, oh my gosh, this tool can do so much more than we thought at first. Yeah, that's amazing. It's amazing. It's also kind of frightening when you're thinking about securing something. Like, great, we deploy this wonderful application. Man, we got it out there, we secured it, locked it down. And it's like, oh no, it just evolved. It evolved. It suddenly got some totally new capability that you hadn't anticipated. Now, amazing, yes. Scary, yes. Right. So one word for this that kind of speaks to the challenges of the fear associated with this is capability overhang. And it reminds me of like old school Donald Rumsfeld quote. There are known knowns and known unknowns, and these are the unknown unknowns. Like, okay, it's got capabilities. AI has capabilities that we haven't discovered yet. And there was research by these researchers at Google when they were doing some of this stuff and highlighted it's kind of novel and quaint now, but doing this research, they found like over 100 plus emergent properties of large language models as you scale them up and up and up, which is really interesting. And to me, that has real world implications with respect to supply chain, because one of the things that we know is incredibly important about supply chain is you got to know what you got. And you got to know what you have, you got to know what you're capable of. And now we're talking about something that is unknowable, right? Probabilistic. That's scary. That's scary. Now, let's rein it back in. We're not going to go off on that like crazy tangent that we could spend years on. Let's rein it back in and talk about supply chain. And supply chain's been an issue forever and ever and ever. Software technically been an issue for as long as we've had software, but it became readily apparent and like front of mind for everybody with SolarGate, right? The SolarWinds breach, suddenly everybody started trying to and failing miserably to get religion about software supply chain because they realized, hey, wait a second. So if we use this application and this application gets compromised or busted, or yeah, that has real world implications for us. And this is not going away. It has not gone away. It is definitely far from a solved problem. And at least from the reporting that I've read and the studies that I've read, it's an increasing problem and an increasing attack vector. This is beautiful for the adversaries, right? There's some economies of scale here. If you can go after one major component that lots of different applications depend on, that's beautiful, right? You just dropped your evil inside of these many, many larger dependencies, which is seriously cool. And we've seen reports here recently that have been highlighting this increase in software supply chain. And that's just software supply chain in general, which is bad and scary and challenging. But honestly, we have a lot better understanding. We can wrap our we can wrap our arms around software supply chain security much more easily than we can Gen AI, LLM, machine learning supply chain. So yes, it is admittedly difficult to do this well, but the general purpose software supply chain, we understand the components. We understand the pieces and parts that kind of go into this. Now, achieving them, non-trivial, but still, we have a sense of them. And one of the things that worries me is that even if we do this well, and we really go after this and knock this down, we could still have additional issues in our LLM-based applications because we haven't taken into account this kind of different attack surface. And to me, the real kind of special sauce that fundamentally changes the supply chain security as it applies to LLMs is data. Data. So this is from MITRE Atlas. So MITRE Atlas, they worked on this project and they basically looked at it and said, hey, wait a second. So AI is this cool, scary thing. And they took MITRE ATT&CK, which we all know and love, tactics, techniques, and they overlaid that and said, well, let's create a matrix specifically for what's going on in the AI world, right? And so they did so. And one of the big high level things that they emphasize is machine learning supply chain compromise. And they highlight this as being materially different than general purpose software supply chain. And some of it speaks to hardware, but a lot of it, and one of the sub techniques associated with supply chain compromise calls out overtly data as a key vector. So data is a key vector. And if you think in terms of supply chain, if you have any passing understanding or passing kind of exposure to software supply chain, then you've very, very likely heard of SBOMs. So software bill of materials. You got some software. Well, what's that software made of? Where does it come from? What are the versions? All sorts of gory details. And what we see here, this kind of pastel rainbow over here on the right, what we see here is the Cyclone DX. It's OWASP Cyclone DX, and it's the bill of materials object model. So you've got these like high level chunks and pieces and parts and all these gory details. And that's really just for kind of software where, well, general purpose bill of materials, but it was created with respect to software. Now, I would submit that data to me is the material difference. Like that's what makes this especially interesting. Yes, there are many other moving parts and components that comprise an LLM application, GenAI implementation. There are many moving parts, but many of them are just variations upon the theme of general purpose software supply chain. But the special sauce is that data aspect. Now, one thing that you find is that this bill of materials, the SBOM, it actually does have some call outs to data. And I was honestly kind of surprised by that a little bit, because my kind of previous exposure, I'm not deep in the weeds of supply chain, software supply chain security, but my previous exposure left me not expecting that, right? And so there are call outs to data. Now, one reason I think that's important to recognize is because it would be really useful if we could, well, leverage it directly, or if nothing else, if we could extend beyond our existing software bill of materials to come up with our AI bill of materials, that ABOM. That's something that AI bomb is something that I've seen referenced by folks. Now, um, and again, to me, that would be worthwhile if we could kind of build on this standard model. And the fact that the standard model does include data, I think that makes that a possibility. And yet, even if we say, okay, well, it's all about the data. Okay, so all you need the data, you need the model, okay. But one of the challenges there is that fundamentally supply chain security is utterly dependent upon transparency. So what do we know? What do we see? What can we see? What are we told? And this is not necessarily, but the idea of like full-blown transparency, yes, we're hearing the vendors and we're hearing the thought leaders in this space talk about responsible AI. And Microsoft highlights their principle of responsible AI. Meta has their pillars of responsible AI. Like everybody has their variation on the theme. And there's a lot of commonality. And one kind of absolute foundational element is transparency. So we got to know. We got to know what we've got, what we're associated with. And this is especially interesting given how many moving parts there are and how many different pieces and parts can comprise an LLM application. So let's say you're building out your app and you're grabbing these different pieces and components. Well, to what extent do you know? To what extent do you know what is actually being provided, what you're actually consuming, what you're actually building upon? To have good supply chain security, we got to understand what's going on. And the reality is, the vendors are quick to point out and say, look, this is a challenging space. So Meta calls out, AI systems are complex. It's important and challenging to develop documentation that addresses people's need for transparency, but also the desire for simplicity in such explanations. And if you scratch beneath the surface here and you have any exposure to XKCD, immediately what's going to come to mind is the XKCD on standards. Oh my gosh, there's 14 competing standards. We need one standard to rule them all. Now 15 competing standards. And the reason I mention that is because we understand that transparency is a need and kind of the world agrees and it's a pillar, it's a foundational element. And then everybody does it slightly differently. And sometimes, I might be jaded, but sometimes it seems like what they highlight speaks to what they want to be transparent about. And that's problematic. So we have, and there's many more variations on the theme, but most of these AI fact sheets, data sheets for data. So each one of those has at least one or multiple academic papers, peer-reviewed articles related to, why is this so incredibly important to transparency? Why is this so incredibly important to kind of the overall security of artificial intelligence and LLM-based applications? And each one is slightly different. It's actually even worse than that, though, because you will have multiple different organizations say, hey, here's our model card. Here's our system card. Here's our dataset card. That's kind of a neat, relatively newish one that started to become more prominent. But they each provide relatively different things. Now, some of it makes sense, right? If you're dealing with a single large language model in total, that's it. Just your application is going to be built upon one single model. Then maybe you can get away with a model card, but the model card better tell you something about the data as well. But then you have folks who say, well, we don't really do model cards, we do system cards. But again, what's included is really important, and equally important is what's not included. So that's just, it's something to be mindful of. So you can see different vendors and different providers highlight each of these different pieces and parts, but even the ones that make overt call outs to the research papers that they're building on top of, many of them deviate substantially from those papers. I mentioned, I didn't highlight the details and the pieces and parts, but I mentioned that, MITRE ATT&CK has stepped into this space and said, hey, look, they planted that stake in the ground, said MITRE Atlas, this is a way of understanding kind of attacks, and then also to some lesser extent, defenses against AI-based applications. OWASP had just a really impressive project that kind of came to fruition and was published, and I think it's tremendous. And this is the OWASP Top 10, which many of us know and love in the application security world. But they created a variation upon the theme where they took that same premise and idea of the top 10. Hey, look, raising awareness, letting us know what's important, but they did the top 10 for LLMs. And some of these, if you've done even cursory investigation into large language models, generative AI, it is not surprising. LLM 01, prompt injection. Not even remotely surprising. Now, we're going to be stepping through some of these the supply chain issues in more detail. We're not going to hit all of these, but you're going to find that a number of them are kind of interrelated. Much like we have in the cloud world, we have our shared responsibility model. There is also a shared responsibility model, whether this is perfect or the standard that everybody's going to go after. The one that Microsoft puts out there is the AI shared responsibility model. And it's very clear. I mean, it even says at the very top of those columns, IaaS, PaaS, SaaS. So they try to fit it within the purview of the cloud-oriented shared responsibility model. And it makes sense given who they are and what their offerings are. But one of the things, if we kind of just step away from the way that they've defined this, one of the things that's going to inform our approach to securing these applications, defending them, protecting, detecting, as well as the supply chain issues, are the extent to which and how we're implementing and how we're leveraging these applications. So if we're just merely making calls against an API, if that's all we're doing, and all we're doing is giving individuals like free access or access to APIs that they can call, then yes, you were dependent upon that black box and that security, and there's not a whole lot that we're going to hook into from a supply chain security standpoint. But the more functionality, the more capability you have, the greater the responsibility, but also the greater the capability you have when it comes to securing that ecosystem. So let's look at one of the ways that large language models and their approach to supply chain is somewhat different than the approach that just general purpose software is. So imagine we've got someone that's trying to build out an application. They've got this wonderful idea, like, oh, this is going to be amazing. I'm going to build out this application. And they try to make life easy on themselves. So they're going to leverage existing capabilities and existing products. So Hugging Face, if you play in this space, you're very, very familiar with Hugging Face. And Hugging Face, one of the things they do is they make a whole bunch of different tools and components and pieces and parts of this overall ecosystem available for free. So we have models and we can go and download these models and we can download the embedding layers and we can download the data sets and get all sorts of details on them. And that's wonderful, right? That the time to application being deployed is greatly reduced. We don't want to reinvent the wheel, and we sure don't want to have to do heavy training given the cost of that, and certainly not with our proof of concept applications. Unfortunately, though, there have been real world instances, and there are also significant concerns when you're consuming these data sets, these models, these embeddings, then they could have been pre-compromised, right? So we've got an adversary here that has uploaded them or tweaked them, and they are messing with the models, messing with the embedding layers, messing with the data sets that you are going to then build your application from. So it's already tainted. In OAuth speak, this is training data poisoning. And it's straight up a supply chain vulnerability as well. They're kind of both interrelated in this case. When it comes to training, we might not be doing full-blown pre-training. Chances are very good that you're going to build on top of an existing model, whether it's like a full-blown foundation model or whether it's a special purposed model that's being created. You could do the full-blown training, but you could also be doing tweaking of that, right? You could do fine-tuning, or you could do variations upon the theme of fine-tuning to try to tweak things. And much like we saw in the previous slide, we do run the risk of someone having poisoned this data. And to me, training data poisoning, my brain immediately goes to adversary intentionally doing evil things, right? So the adversary has done evil things. They've added evil in there so that we're going to consume and build on top of that evil. That feels very supply chain security issue. But something that I think is honestly even a bit more insidious is that we can inadvertently have substantial issues that will crop up in our applications just based on the data sets, just based on where we get our information. Maybe you're consuming a whole bunch of toxic information or copyrighted information or, sensitive information of one stripe or another. And suddenly now you build on top of this huge volume of training data or fine tuning or what have you. And now baked into the DNA of your model in a manner that's not terribly easy to identify, you now have some of these issues present. So let's see how this might impact. We've got our end user, and this is overly simple, right? We're not going to dig into, hey, they've got a prompt, and then we got to tokenize it, and then we got to, convert it into embedding for vectors, and then we're just going to keep it simple. You got input, you got output. Input is the prompt, output is the response that's going to be presented to the user. And, that's the way that things we hope will work. Now, it's not all about bad actors. We can absolutely have, unwitting users that are going to cause problems either by submitting sensitive information or by, just accidentally running afoul of something that you consider to be, an issue. And this is regular old user just either because your policies aren't defined, they don't know the policies, they run into issues with sensitive information having been disclosed, or potentially we don't know what that data set looks like. It could be insecure output handling, meaning that something that perhaps the adversary injected into is going to be presented to the user in a manner that's going to potentially expose her. What we are more overtly concerned with is the intentional bad actor. And this is at the inference layer. So this is you're interacting with a model that's been trained and tuned and however. The adversary here is intentionally trying to submit malicious information. And this malicious information can be in the form of what's referred to as direct prompt injection or indirect prompt injection. And we'll kind of leave that there for a second because seeing us interact with the web directly from the model is a variation upon the theme. Now, in some respects, conceptually, this is a known problem, right? You've got somebody that's sending potentially sketchy or evil input. Well, yeah, that's every application in the world, right? Users are evil, sometimes just intentionally so, sometimes unintentionally so, right? And we have to assume that all input is evil, it's unsanitary, it's going to run afoul of all sorts of issues. So, of course, we're going to do input filtering, we're going to do input validation, we're going to do input monitoring. Okay, how do we do that? And we'll see here in a second. But that conceptually, it's very, very similar, right? Very similar to the way that we would defend just general purpose applications that accept user input. But the idea here is that we filtered it meaningfully and it blocked the sketchy response, the evil, the sensitive information disclosure. A different way of achieving this is through what's sometimes called the system message or system prompt. And the idea here, this is also potentially I wouldn't call it input filtering or validation, but the idea is that we're going to give instructions to the model itself to tailor the way it behaves. And so this model is told how it's to behave. Now, every model has its own kind of inherent system prompt that we're not supposed to be aware of as end users. But if you're developing these applications, then you can certainly implement your own system prompt. You can add in some additional instructions that can be taken into account before the prompts are responded to, before they're processed. So the idea here is that we have some system prompt that's intentionally trying to defend the application, and it's seeing this malicious, harmful, sketchy input, and it steps in and blocks it. Okay, no harm, no foul. So it's still on kind of the, in some respects, this is kind of the processing piece, I would say, not really input, not really output, but kind of that processing piece is where we're stepping in and interdicting. And then we also can do this on the output side of the world. If you've ever dealt with web applications and cross-site scripting, you know that it's kind of simultaneously an input flaw as well as an output flaw. And we want to make sure that we account for both and handle and safely handle and monitor and sanitize and filter both the input side and the output side. And it becomes all the more imperative when we start chaining these things together to build more robust applications. Now, conceptually, input, output, processing, that's not new. That's not new at all. But how do we actually pull that off? And there's variations upon a theme. There's different ways of achieving this. One that I'm excited about is Meta's Purple Llama project. Now, really, the Purple Llama is the umbrella project that includes multiple pieces and parts. So far, they've released two kind of papers and attendant kind of tools and things like that. First is cybersecurity eval, which is really focused on trying to come up with a meaningful way of assessing code generation and code creation and trying to identify the generative AI or LLM system producing insecure code. One thing that I just want to the reason that I included this is to give a shout out that one significant observation they found was that the more advanced models had a greater tendency to suggest insecure code, which I thought was just kind of interesting. Now, the real reason to bring up Purple Llama, though, is because of Llama Guard. And Llama Guard, I said conceptually, input filtering, validation, monitoring, output filtering, all that stuff. How do we do that? Well, one way that we can do that is with Llama Guard. And this is from Meta. This is open source tooling. And what it is, it's a tweaked model. It's an open source model that has been tuned, version of the Llama 2, that has been tuned specifically to try to deal with input and output in what they characterize as human AI conversations. So user does something sketchy. Llama Guard has one component where it does what's called prompt classification. And it says, wow, that's toxic. Wow, that shows bias. Wow, that is attempting to jailbreak or prompt inject. Right? There's different variations upon the theme, but it can also hook in on that response side. And so this is one tool that can be hooked into your overall LLM pipeline, LLM app pipeline, to really implement and bolster some of that security. And again, in an open source manner. There are a number of commercial players in this space that have stepped up in relatively recent time frame. But me personally, like we struggle so much with transparency already that the idea of being able to leverage an open source model, they've got their model card, their system card that they disclose. To me, that's quite useful. Now, we had our application, we had our input, and one of the things that I showed was when we were showing the prompt injection, I showed that the adversary could potentially do that indirect prompt injection. And really that was hinging upon what's sometimes referred to as RAG, or Retrieval Augmented Generation. Your trained data set, your pre-trained data set, it's got a specific cutoff date. It's only so current. Its knowledge of the world stops at some specific time when all that training data was gathered and was fed in. Well, we don't love that, right? We want to augment that. We want to augment that with current web searches. We want to augment that with current data. We want to augment that with our own data, and kind of all those different pieces and parts. Sometimes they're referred to as retrieval augmented generation. So the LLM is going to retrieve something and then take that into context. So you have your normal user submits their prompt, and instead of immediately going to response, the idea here is that the LLM is going to process it and say, hey, wait a second. I think I need to do something. I think I need to check something out. And it realizes that it's based on what's been supplied. It's going to reach out and pull current information or contextual information from, I'm showing here in the web in this case. Then it brings together that prompt, the user input prompt, as well as the context it's retrieved to then formulate the response that's going to ultimately be sent back. So the idea is that you get more current, more relevant, potentially data that is present here. But of course, the risk is, now you're hitting against potentially live data sets, potentially, right? It could be something that we feed and we feed into a vector database or something like that. But now you're potentially dealing with live data sets, and that whole data transparency, data security thing becomes an even more substantial issue that's harder to solve that problem. One just kind of passing mention, we are rapidly moving towards agentic applications and LLMs, and agentic applications and LLMs, which is basically, the LLM in and of itself doesn't do anything, at least not in its kind of basic construct. But the idea is we're now taking it and saying, hey, wait a second, those LLMs are pretty good at reasoning and coming up with plans and things that can be done. If we just give them the tools to do this, then we can extend their functionality greatly. And that's where the idea of assistants or agents are coming in, and they're becoming a bigger and bigger and bigger deal. But of course, then you step into some additional of those OWASP top 10 for LLMs. You end up with over-reliance, so over-reliance on a tool. But another one is having increased capabilities with the plugins, and then having the extensibility and actions being taken. So if you want to check out some kind of current tools in this space and code in this space, AutoGPT is an open source AI agent, and they also leverage, there's an open API agent protocol that tries to come up with a standardized way of interfacing with these open AI agents, which is really powerful, and then it tries to extend beyond this. Well, I opened up this talk with a quote from Battlestar Galactica, and I'm going to end it with a quote from Battlestar Galactica, just to cap end it for you. This is from Bill Adama, Admiral William Adama, who is the commander at one point of the Battlestar Galactica, and another one that just kind of felt relevant to me. You cannot play God, then wash your hands of the things you've created. Sooner or later, the day comes when you can't hide from the things you've done anymore. And again, we're building these applications that we don't fully understand upon data that we don't fully appreciate all the nuances and bias and uncleanliness that's in there. And this is rife for security concern but also security appreciation. So anyway, I had fun building this out, and I hope you enjoyed it. And absolutely let me know. If you have, reach out if you have questions, connect with me, and reach out if you have questions or want to chat more. Other than that, I'd love to see you in 511 and talk more about this fun stuff.